Hello everyone and welcome. Welcome to this session from codeLive. My name is Philippe. I'm a developer advocate at Salesforce, and today I'm gonna be talking about custom REST endpoint and when to use them and also when not to use them. So in this session, we're going to be seeing different set of resources, and I'm going to be writing some code, and I'll try to make some stops to ask some questions. And I cannot guarantee that I will answer all questions, but I will try to make some pauses and look at the chat. So feel free to go ahead and type your questions in the YouTube chat. I'll try my best to look at them, but yeah, this is going to be a nice ride. All right, so let's get started now. Before I really take a look at Apex code, I want to talk to you about the alternatives to writing custom Apex REST endpoints. It's very powerful to write those endpoints, but there are also a number of things that let you achieve more or less sometimes the same results without having to write any code. And remember that code that you do not write is code that you do not have to maintain. So it's always good to keep that in mind. So to begin with our session, we're going to jump to Postman. And Postman is an API tool that an API client that lets you use all sorts of APIs from the Salesforce ecosystem. And today we're going to use one set of API, a collection of API that I've created, and I'm going to use this to show you some of the alternatives to custom REST Apex endpoint. So this is the Salesforce Platform APIs. This is something that you can grab from the Postman API network, which is their marketplace. And as you can see here, there are a number of APIs, and some of these can be good alternatives to writing custom REST endpoints. The first and obvious choice here is using the basic REST APIs. So with those APIs, you have access to CRUD operation, create, read, update, delete on records. Now, this is a good start, but often one of the problems with that is that you're limited in terms of what you can do by chaining operations. So, for example, here a very useful query, the actually the request called query, which lets you run some so-called code here. So for example, if I let me actually change the entity here, so I can request 200 accounts here with this query here. So that's a simple way to run a so-called query and then return a set of results, as you can see down there, with all of our attributes. So this is very helpful. Now, the problem is you can chain multiple REST requests, but unlike Apex, they do not live within the context of a transaction. So when you do an integration, this can be problematic because if one of your queries or operations fail, you can get into an unstable state and you have to manually roll back the operations that failed in order to recover a stable state. With Apex, you don't have to worry about that because there's the principle of a database transaction, so everything gets rolled back to the beginning of the operation if anything goes wrong. So that's one of the alternatives. The REST APIs are good, very efficient, they're very powerful, but they're limited outside of transactions. To compensate for that, we have something called the Composite API. And the Composite API allows you to chain certain operations. So here, for example, with the Composite Graph API, we're able to chain certain requests. And here we're looking at a post request that will create first an account. So it's using the endpoint from the REST API to create a new account with a given name and a custom field. And then it specifies a reference ID that we can use in another query. So here, there's a second query here that allows us to get the information from the account. So if I were to run this, which I'm going to do now, we're going to create first, in the first request, a new account named Acme, and we're going to execute immediately a second request, get, with the new account ID that you can see here. So here, if I look now at my responses down there, actually I forgot, yeah, I don't have any custom field in this org. So let me just remove the custom field here for now. I'll just use the name field. If I run this, what you'll see here is we have also a graph of responses. And the first one is the success operation for creating the account. So we can close this one. And the second one is the account information, including the ID of the newly created account with name Acme. So you can see with Composite Graph API, we can chain multiple operations and you can pass references, such as, for example, the reference ID here, between the different requests. So this is going one step further than the traditional REST API. It allows us to chain a number of operations. A bit more powerful than REST request, but it requires a bit of processing in order to sort and compose the graph. Other alternatives, another one is the UI API. It's an equivalent. It's not an equivalent. It's also using the REST format, and it allows you to look at record information. For example, if I were to grab the ID of my newly created account down there, I can retrieve the information from my object. So here it was a where is it? Here, yep, an account ID. So I can retrieve my account ID, and we're going to see that it returns for us a lot of information. So this returns two different things. The UI API is good for retrieving the record data, but also the metadata of the record. So what you see when you look at this here is that you have information about the layout of the object. You have description of the different sections, the fields, etc. So I'm just going to collapse all of this. The object information, you see the fields, the types, and if we go really at the bottom of this, we'll have the records that we have selected, for example, our account with all the different fields. Of course, it looks a bit empty now because this is just a sample account that we've created. We only filled up the name. So if I were to go down, there's probably the name field down there. Yeah, here with our Acme Inc. Record. So UI API is great. It's generally more useful when you need to create a user interface because you also have the ability to retrieve the object metadata. So that's another consideration. And finally, one last thing which I can show you as an alternative is also the GraphQL Beta API. So this API is somehow a bit similar to the Composite API. It allows us to chain multiple operations, but there's one restriction right now with the GraphQL API is that it's read-only. It can be only used to retrieve information. So here, if I were to look at accounts, for example, I have a query which allows me to retrieve an account with a specific value, and if I send this, I'll be getting information about my accounts with just the names here. Here you can see our Acme account here is there, and there's also another one that was already on my Scratch org. So this is a simple example, but it can get powerful because you can compose a request here. For example, another example with some filters. You can add a where clause. You can actually build almost a SQL query with this, and in some cases you can build different trees with cross-linked requests. I think this one is another good example where you mix contacts, accounts, and other things. So here, for example, it would retrieve the contacts from an account. And this is not something you can easily do with other types of APIs, but with this language here, you can build up those complex queries. So that's it. I'm not going to spend more time in Postman. This is just to prove the point that in some cases you do not need to write Apex code to build custom API REST extensions because you can leverage some of the API functionalities that are part of the product natively. So again, I want to stress out the fact that code that you don't write is code that you won't have to maintain. All right, now that being said, let's really jump to Apex. And that's really what you're here for, looking at some Apex code and working with Visual Studio Code to create. Oops, I closed this. Sorry, I'm not used to working on a Windows machine. I generally work on a Mac, and I've mistaken my shortcuts. Never mind. All right, making this a bit larger so that you can see it. I'm just going to do a brief pause here to check for questions if there's anything that I missed. Okay, no questions for the moment. All right, cool. Make sure to keep them coming if you have any. I'll try to again do some pauses when needed. So we saw the alternatives to writing custom REST endpoints. Now we're going to take a look at some how we can write an Apex endpoint. So it all starts with a Apex class. So I'm going to create a new Apex class here, and I'm going to call it say hello REST resource. So I'm going to be doing some sort of hello world here to basically showcase what we can do with the REST APIs. So this is a traditional class. Now what we want to do here to expose it as a REST endpoint is add an annotation to it. And I'm going to be adding an annotation called REST resource. And unfortunately the auto completion doesn't work for me, but anyways, the REST resource, and then there's a parameter called URL mapping here, and it allows us to provide a name. So at this point, I'm looking at sideways for my notes. You may have noticed because I don't know all of this by heart. And what this does here, I've added this annotation REST resource, and I specified an endpoint for it. You'll notice that in my endpoint, I have a partial URL. This is not a full URL. It's starting with a slash. It's a relative URL. And this is going to be tied to the Salesforce platform base domain. And you also notice that there is a wildcard character here. And so what this means is that we're going to capture requests for multiple URLs starting with slash slay dash hello slash. We can have more than one wildcard character in here. So if, for example, I was calling something like say hello, this would capture it. If I were to say hello Phil, for example, this would also capture it. Now, that's the first step. So we have our class here, and when you work with REST, there are a number of verbs that we need to support. Verbs are, in other words, HTTP methods. And there's a number of them, so maybe it's the time for us to look at the documentation. So I'm going to bring up the documentation. And we have, very convenient, they're all here. Google does a really good job at summarizing everything. So all of these here, let me actually open this up a bit bigger, are the different annotations for the different methods that we support. So in our case, we're just going to do a hello world, so just going to start simply with a get endpoint. So I'm going to use this API method here. I'm going to add it here, and then I can write my method. So for my method, I'm going to be creating a global method. I'm going to be returning a string to start simple, and I'm just going to call it doGet, for example. That's good enough. All right. So what this does now is that it exposes an endpoint on our URL mapping with the get method. We can combine multiple methods on this particular endpoint. And here, for example, I can just directly return a string world. All right. Simple. That's already all it takes to create a very basic REST endpoint. Now I'm going to deploy this, and we're going to be seeing how we can test this. So I'm going to deploy it with for source push. And oh yes, I forgot one important thing. The class also must be declared as global, not just the method. Everything needs to be declared as global. Pushing again. That's the magic of another thing. I did it wrong. Global static. The endpoint methods need to be static. That's good. The error messages are pretty clear, so it shows me what I'm doing wrong. And there we go. So now the thing is uploaded. So let's see how we can call it using Postman, for example. So I'm going to switch back to Postman, which I closed by mistake. Damn. All right, let me see if I can open it again. I hope I haven't lost my session. Yes, I'm still in. So let me reopen my workspace. Hopefully it's still authenticated. let's see. Here, looking at my collection of requests, and here you have an endpoint called Apex REST. And what you see here is that there's a specific URL that we need to call /service/Apex REST, then the URL mapping. So for URL mapping, it's going to be the same value as we had before. So say hello. I'm going to use this. And what endpoint is the domain for my org. So this is what we have here. Now let's try and run it. I'm going to send this, and here we have world. I should have said hello world, but anyway, it proves the point that my REST request is working. And we'll be using this, and we'll iterate on requests. Now, I want to point out one important fact here as we build the request and the endpoint. One thing that is very important that I did not mention earlier is that when you write endpoints and you build the a REST API, it's good to align with REST standards. And part of the REST standards say a number of things. For example, here this bit, which is part of the URL, is case sensitive. So this is different from anything that you do in Apex. Apex is case insensitive, but the URL mapping is case sensitive. So be very careful if you put capital letters in there. This will be a problem for your, I mean, it may be a problem whenever you call those endpoints and you forget the capital letters. As a convention, URLs are generally lowercase. So try to keep everything lowercase, and also try to use this kind of style to avoid any weird characters like spaces, question marks, or stuff like that. So that's a good start. So instead of saying world, I'm going to say hello world, which is a bit better, I think. So that's already our first API call, and we're going to explore a bit further now. So the next question is, how do we pass in parameters to our REST request? And before I jump into this, let me again check for questions if there are any questions. All right, I have a question in there from Satyajit Paul. Can we have a dynamic URL like API v2, API v3 to serve different versions of the systems on the system? Or do we need two different Apex classes? So that's a very good question. I think it's it's a bit advanced for now, but yes, the answer is yes. It will require a bit of engineering. There is no, I would say, native way of doing it. But since you have access to wildcards here, you could have a master REST resource that calls subclasses that are in charge of serving the different API versions. So for example, here you can use I'm sorry, I'm looking for the word. You can use dynamic types. Sorry, decoupling. No, dynamic instantiation. Sorry, yes, that was the word I was looking. To automatically load a class when you extract a version number from the URL. So if I were to say, for example, v2/this or any version, I can dynamically here use class instantiation to load an Apex class to serve the responses that are prefixed by version 2 or version 3. So instead of writing the version directly here, you can leave it with a star and extract the version from the end of the URL. But this is a bit too advanced for now. I cannot show this in this session, but it is feasible. If you're interested in looking into this, there's going to be a blog post which will summarize what I'm going to share today. And there's already a blog post that is maybe a year old on dynamic class instantiation that you can look on our website, and it will teach you at least the dynamic part of spinning up dynamically Apex classes. And this is a good use case supporting multiple REST versions. Let's see. I see other questions that are more related to APIs. Yes, some people are looking for the Apex workspace. Yes, it is available online. I'll make sure to post it in the resources. In the meantime, I can already show you the URL. All you need to do is to go Postman, postman.com/Salesforce-developers. There you go. So when you do this, you land on this page here, which contains some of our collections. And the one that I just shared today is the Salesforce Platform APIs. There's more than that. You'll notice that we have also collections for Commerce Cloud, Marketing Cloud, Pardot. But I think the one that is the most complete is this one. That's the Platform APIs. And when you get to this URL, you can fork it and then you can start using it. So if I click on this one, I'm on the public documentation for the API. And if you follow the documentation, it will teach you how to get started, how to clone it, how to get started using it. But let's not talk too much again about Postman. I think we need to get back into Apex. All right. See, looking at questions. Um, do you have any idea if REST API needs to get more than 50,000 row data in a transaction? Well, if you need to get more than a certain number of records, and I don't know I forgot what's the limit, but we can check. You can use the bulk API, which supports an almost unlimited number of requests. So the bulk API, version 1 or version 2, is your go-to solution. When you hit the limits for the REST API, you can work with the bulk API. It supports much larger volume of data. Now let's go back and rewind, go back to Apex. All right, so we have our basic requests here, and we will now look at how we can retrieve parameters from it. So there are a number of ways of doing it. In some cases, we can work with method parameters. So here, for example, I'm going to change this a bit, and I'm going to use a parameter here. This is using a body parameter. So this is not working with a GET request. We need to switch to a POST request, but we can also work with, yeah, let's do that. Let's switch to POST for now, and I'm going to show you that. So I'm going to change the verb here. We're going to switch to a POST method, and I'm already going to provide a parameter in there. Now I'm going to redeploy this method and just make sure this deploys correctly. And then I'm going to go back in Postman. I'm going to change the method so that it works. And what I'm going to do now is I'm going to add a body, and I'm going to add a parameter in our body. So I'm going to say name. Oh, I need to put the columns there. Name. There we go. So I have a parameter in there. I'm saving my request, and I can send it again. And oh, I forgot to add my name in my response. So never mind. Let me just fix that. I need to change this to include my name. Obviously, we won't see the right value if we don't do that. Redeploying. Right, now relaunching the request, and here we go. Hello, Philip. So what we saw here is how we can pass in parameters using a request body. The request body only works with all types except for get. So it's not working with the get type. Get requests by convention on the REST APIs are not supposed to have a body. So that's a good tip. You can still work with when you have to use a get request, you can use query parameters, which I'm going to demonstrate next. All right, so we saw this. Let's now take a look at how we can move beyond this simple use case. Up till now, we had input and output using the method parameters and the method return value. But when we work with REST, we have access to more powerful things. We have access to something called the REST context. And this is a system class object which contains two things. And yeah, damn, the auto completion still doesn't work. All right, never mind. Let me see what's the value here. That's request. So we have two things, request, and the same thing with response. And I'm gonna save these value as, look at my notes here, REST request. Obviously, this is all documented, but I'm saving you the back and forth between this and the documentation. All right, I'm just gonna call it rec to have less typing, and REST response. REST. All right. So this static class here is providing me with two things: the request and the response, which I can extract here as two objects. Now, with this, I can work totally differently. I can turn this method into a void method, for example, and I can remove also the parameters from here. And from request and response, I'm going to be able to extract parameters. So I can remove this part here, and I'm going to try to do this with a bit of code. So here, for example, if I were going to use the request, I can do rec. And here you can see I have access to a number of things from the request. This time the autocomplete works fine, so I can see the method that was called. This is useful if we have more than one annotation on our method. So for example, if this doGet method, which I forgot to rename by the way, works for post or for anything else, we can see the current method that is being used. And the fact that I forgot to rename this brings a good point. The name of the method is totally not relevant for the functionality of the API endpoint. I can call this method whatever I want. As a convention, we try to stick to the verb here, but it doesn't really matter. It's not being used anywhere else in Apex. It's just for us. If we do some debugging, it's better if the method has the right name. So again, we see the headers, the method, and the parameters, and the request body. So the request body is what is of interest right now. We're going to be looking at the request body. And the request body in our case is it's not a string, it is a blob. The REST API works with any data type. So you could be posting some text, but you could also be posting some binary data. So this is why the default type is a blob. So if you want to work with strings, which is, I think, in most cases what we do, you have to call a toStrings on it. Otherwise, you can read binary data directly from the request body. All right, so we're retrieving the request body. Here I can simply just use it in my response. Ideally, what I want to do now is parse it. So I can write some fancy code, but I'm just going to do something very simple. Looking at my notes again, I'm going to do something very simple. I'm just going to do a let's see if I have it at hand. I'm just going to see if I can extract this as well. I could be trying to do this. JSON dot deserialize. I'm going to be deserializing my string as a map. This should be good. I think if I do this, let's see. I'm not super sure. I'm trying this live, so I forgot. Well, maybe just a map. Let's see. Or yeah, maps. Do I need to specify the type? Let's see. Doesn't seem to be happy. Let's see. Well, I'm gonna maybe have to copy paste some code here. But you know, that's the life of a developer. Often you have to do that. All right, so let's say we do that, and from parameters, once we have the correct code to parse it, I'm gonna be getting the name parameter, and I'm gonna say save this in a string. After that, let's work on the response. So for the response, we can also set the response body. We can set some headers if we want to return a specific headers, and we can set a status code. Status code is super important because when you use the return parameter from the method instead of void, you cannot control the status code that is being sent back to the client. So if there's an error, you don't have access to this. It's always HTTP 200, which means the request has completed. Now I'm going to use a response body. So here I need to set a blob. Remember that we're not sending necessarily a string request. It can be also outputting some binary data. and I can use value of to output my data. So I'm just going to write hello with the name parameter. All right, now I think I need to fix this part, which is it's probably not the right thing. So let me just have a quick look at JSON deserialize, make sure I get the right. Google is our friend, as always. All right, deserialize apex type. Let's see if we can have an example. Oh, I forgot the dot class. That's the thing that I missed. All right, never mind. That's what I was missing. All right, now I do need to cast it to the right type. Okay, so let's see. How many of you think that this is the right code? I think this is looking pretty good. Let's see. Yep, that's right. Let's see if it. Let's see first if it deploys, and then we can see if we can run it using our. Oh, what is that? Does not exist parameter. I missed an S here. Oh yeah, parameters with an S. That's better. And variable doesn't have a JSON string. Yes, because it's not JSON string, it's request body. There we go. All right, now this code seems to be deploying. Let's see now if we can run it. So again, using our the same request from that we had before. Let me clear the response first so that we can see that it's the right one. Let's see if I can clear that. How can I clear the response? Let's see. I'm pretty sure I can do that. Huh. Well, of course I cannot erase this. Let's see. Is there a way for me to clear the response? Nope. I don't want to save it. I just want to clear the response. Well, I'm just going to change the value of this thing so that we should see a new variable. All right. So sending the request again, and here you can see that it works. Well, that's pretty impressive. It works on the first try. So I was able to parse the string that is in the JSON that I passed in my body, and I was able to extract the name parameter and return it in my request. So here by default the status is 200, but if I wanted to say something else, like for example 202, a different code, we can use res.status code to change the status code. So here we can pass, for example, 202. And if we run again the request, redeploy first and run the request again, we'll be able to change this. Sending again, and you can see now here we have a 202 accepted. So it's important to familiarize yourself with the HTTP status codes, because this is something also that is part of the REST standard. All of this is documented. Each of these status codes has different meanings in different use cases. So make sure that you leverage the ability to use different response codes. I think it's important to have resources well structured, and well architectured. All right, let's see. Quick break for questions. Let's see. I see another question. Is it possible to access this API in an anonymous way, so without a username and a password? So something that I did not show here, because I already set up this Postman collection before we came live on the stream. The requests that are made to this endpoint are authenticated. I am passing in the headers it's actually hidden, but there is there's behind the scene an access token. So this requires a session. If you want to create REST requests which are anonymous, so meaning that they do not need a Salesforce access token or no credentials, you'll have to use an Experience Cloud site, and that is a bit of a hack. Generally, we require a token for accessing custom Apex endpoints. So I do not know if this hack still works. It used to work using an Experience Cloud access with a guest profile, but don't quote me on that. And in any case, I'm not sure that this is supported officially. So the answer is, in most cases, you have to use this just from a technical standpoint, but also from a license legal standpoint. You do have to use licenses when using Salesforce. Um, all right. Some people were trying to help me for the JSON parsing. So thanks. I saw that a bit late, but it's always good to know that I have fellow devs helping me. Uh, can we convert a JSON request body into a specific Apex class? So yes and no. So we can parse Apex using the deserialized method here. So in this case, I use just a map here, but we could have a custom class here that we could deserialize to. Now, we're not going to be able to get the methods, but we can have some wrapper classes with the right types and fields. And there are other methods from JSON body here. You have, for example, deserialized strict, which allows you to force the matching of the JSON string to a specific Apex type. And if some strings or some properties are missing, it can throw some errors. Obviously here I went a bit fast. I did not have any control structures. I did not do any try catch. It could be that the Apex, the bit of code that I'm sending here is not valid JSON. So we can try this. Actually, let's try this. So for example, if I send something that is not valid JSON, we're going to see that our endpoint is going to crash, and here you can see the error status 500. So this is the default error here. Obviously, we can do something a bit more intelligent, so we can try this in a different way. So let's try to catch this use case. That's an important thing to do because when you write custom REST endpoints, you have to validate the different parameters and you have to provide helpful error messages. So what you want to do in this case is do a try catch around the deserialization part, and actually we can actually use all of this and put it down there. And if there is an error, so if we catch an error, so we can return an error. So the error, I'm still going to keep the 500. I think that's a pretty good use case. Or actually, no, we can have something else. We can have a 400 error. So always when you look at REST, it's always good to have some sort of cheat sheets with the different status codes. And all those the REST status codes are ordered by range. Everything that is in the range of 100 is informational, 200 success, 300 redirection, 400 client error, 500 server error. So in the case of an invalid formatted request, this would typically be a client error and not a server error. So the server will be saying to the client, no, you do not have the right format of your request. So I'm going to be looking at the 400 errors, and I can just use a HTTP 400 bad request because it's not in the right format. So for example, malformed query syntax, something like that. So this would be the right type. Instead of sending back a 500 error, we should be sending a 400 error. So let's fix that. So here, if there's an error, I'm going to throw a 400. Let's see if I can just do that. And for the response, I can use. So here I have two options for the response body. I can, of course, directly output the error from the exception, but this sometimes can be dangerous because sometimes you can expose some underlying implementation of your code. So you can either do that or you can write some error codes which are not necessarily transparent, and you can log some things in there. In our case, I'm just going to output directly the error code here, and we can work with that. So what I meant here, maybe I went a bit fast. What I meant here is that sometimes you do not want to display the entire error stack to your client because it can contain sensitive information. So instead of showing the exception, you can write your own custom error message. So like malformed request, and then you can use a logger to log the details of the exception for your admins, server admins, to look at what happened really behind the scene. All right, so let's try again to run this request. And now you can see that we have a 400 bad request instead of a 500 error. And I've just have the same error message here, but this is because I did not change it, but I could write my own error message in here instead of having the other one. Notice that we no longer have the stack trace, so we have no reference to our source code here, no line number, no file name. This is probably a bit safer than outputting all of this information, which should not be in contact with the client itself, especially if you're sending anonymous REST requests, because this is one of the reasons why we generally do not allow this, is that it's kind of a security risk, of course, if you don't secure all the code. So yeah. So that's the basic for issuing a request. You can explore all the parameters from REST request and REST response from the context. Let's now take a look at how we can write some tests for our query. So I'm going to go back to VS Code, and we're going to try to test our little query here. So I'm going to create a new class here, new Apex class, and I'm going to, well, it's going to be a bit of a long name, REST resource test. And that's it. So we have our test class here. I'm annotating with this test. I can already drop this part here, and I can even make it private, in fact. All right, we don't need a constructor, and we can write our test. So let's say a private start with the basics, say hello works. And in order to test our class here, what we need to do now is a couple of things. Obviously, we can test in different ways depending on whether we have used return parameters and parameters directly in the request, or we can also use a fake REST context. So I'm just going to jump directly to the advanced use case where we use REST context. But if you were already setting a return value and parameters in the method itself, you can just test the endpoint as a typical method in Apex. You wouldn't even care about the fact that it's a REST resource. So let's move this side by side so that we can see both of our classes at the same time. I think it's a bit easier to see this way. Now, what we want to try to mock now is the REST context. And so the good news is that we can use it in our test. So what I'm going to do now is I'm going to create, I'm going to inject a fake request and a fake response to our REST context. So I'm just going to grab this bit here, and I'm going to create a new, what is it? This is called a new REST request. Simply like this. You would never call this constructor directly in the live code. This is only available in the test code. So this is useful for faking the request and the response. Copying request and response. There we go. So now we have faked the request and the response. All we need to do now is to set the values like we want them to be. So for example, here we have access to the request, and we can set the request body to whatever we want. So I'm going to do res. Actually, I'm going to use rec. Sorry. I'm going to do it a bit differently. Sorry. I forgot to save a reference to my object. So let's do it a bit differently like this. We need a handle to our REST request and response. That went a bit too fast. Oops. Rec. And I'm going to do the same thing with my response, saving it as res. Oops. All right. So we create our two objects, we inject them in the REST context. Now, from the object, we can access all the different fields. So we can specify a fake request body. So here what I'm going to do is simply take the bit of code we had here, for example, and here we can pass in our JSON data. So I'm simply going to go to minimize the risk of errors. I'm going to go back here and just grab this part here and put it in there. Oops. I can change the value here. Well, it doesn't matter. I can keep this. That's fine. So this is the request that we're sending. Semicolon here. And for the response, well, we're going to be able to read the response in our test. So let's see. What you need to do now is call the method. So to call the method, well, it's just a method. So we can just call a say hello static REST resource do post. And that's it. Now this is going to be handling for us the request. So what I can do after that is read the response. I can write my assert. So system. I want to make sure that I have a 200 for the response code. And I want to make sure that actually it's not 200 anymore. It's 202. Sorry, I almost got caught. I changed it recently. And I want to make sure that my response body is also hello devs and reading the value. Oops. Response body to string, and that's it. All right, let's deploy that and we can run our test. Is this method? Oh, yes. I have a problem with static methods. It looks like it's not the first time I'm doing this mistake. All right, let's do it. Redeploying now. All right, no syntax errors, looking good. And well, I was about to open Postman again, but I don't need to do that. And so we can either run it with the CLI here, or simply I can also use these little shortcuts there to run it. So I can just going to do that for now. It's going to be even simpler. And here you can see that the test is passing. It is behaving as expected. That's cool. All right. So I think you get the point. After that, it's a matter of combining the different values for the status code, for checking if we have an exception. So if we have a 400 error, it's when we provide something that is not valid. I mean, I can do it right now. It's going to be very quickly. Fails when invalid input. All right, and I'm going to be expecting a 400. And for the response, I forgot what was the text. Well, let's say that it's. I'm just going to simplify here. And I'm just going to be using this invalid request format string that we can simply check here. And that's it. Now, if I redeploy all of this, I can run this other test, and we have a test for the failure case. Let's see, will it pass? Will it pass? No, it doesn't. Invalid request format, except character. Oh, well, actually, it is expected. So that's one thing. The exception here got out of the post, so I would have to do a try catch around it. So I'm not gonna catch it here. I'm just gonna leave it caught, but I'm still gonna run my test just after. If I were using other formats of exceptions, I could do this differently, but that should fix it. And oh no, still not. So that's well. Let's see. So the parsing is failing. So this is the one that is throwing the exception. So maybe I should just catch the right exception to prevent it from propagating. So let's see. What's the exception that this throws? I forgot. Where is the exception name? Ah, damn it. Where is the exception name? Obviously, this code is not checking for exception. Let's see if I can find it. Hmm. Oh, nothing to do. Exception, exception. Well, I would have to find the right exception time, but I think you got the point about how this works um, and how you can test it. Alright, I'm just gonna skip this part for now, and I'll be looking at questions now because I see that there are a few questions that have landed in the chat. So let's see what we have. Alright, looking at questions now. What do we have? Class. If the payload matches the structure of an Apex class, yes, you can match it to an Apex class. Yes, that was something we covered. How can we support the content time form data for the request body? So I guess what you mean is not form data. It's probably gonna be something with multi-part data, I guess. Because when you write a request, let me show back my screen here. When you write a request, you have different formats, and you can encode your data in multiple ways. Form data is one of them, and this is a structure that you can provide. I haven't tried it recently, but you have access to resources to read the headers and to see the expected format, because all of these types of bodies are actually also identified with headers. So I didn't show that, but there is a content type header that is automatically set. By default, when you do a post, it's application JSON, but you can provide other types here which will let you decode other types. So if you were passing form data, you would have a content type form data there to specify that it's a form data. And same thing for multi-part data. You can create multi-part requests by specifying the right headers there and encoding your data in the right format. Let's see, are there other questions? Is the endpoint working synchronously or asynchronously? So, well, the endpoint is working synchronously, but it can take up to 30 seconds. That is the default timeout for an HTTP request. So if you have a long-running operations, you would have to keep track of it outside of the execution of the endpoint. So for example, you could start a job, but you will need some data to keep track of the job that is running in the background and call another endpoint method to check the status of the job. You cannot have a long-running operation in a single endpoint call. And I think that's it for the questions. So thank you so much for joining and being with me here today. I'm glad we did this whole stream without any major fire. We're able to compile the code and make it work live. We saw during the stream all the resources that are available as alternatives to writing custom Apex endpoints. We saw things like the REST API, the Composite API, the Composite Graph API, sorry, the UI API, and the new brand new GraphQL API. We saw how to use them with Postman, how to use Postman to test these APIs, and also our custom Apex endpoints. Then we saw the Apex code that is required to write all sorts of different custom REST endpoints. We saw how we can handle errors, how we can return different types of data. And we also saw how to do proper testing for our endpoint. That's it for me. I hope you really enjoyed this session and stay tuned for the next codeLive, hopefully next week. Thanks everyone. Bye.